They say the universe is silent. But what if, just once, we heard it whisper back? Billions of miles away, far beyond our solar system, the James Webb Space Telescope has captured something extraordinary. A strange, faint signal, hidden in the delicate light spectrum of a distant exoplanet. Its name? K2-18b. Until now, it was just another speck in the cosmos, lost among thousands of other planets. But something has changed. In its hazy, hydrogen-rich atmosphere, James Webb has detected traces of molecules that, on Earth, are often linked to life. Not just water vapor, but dimethyl sulfide, a gas we know is almost exclusively produced by living organisms here at home. This single clue could rewrite what we know about life in the universe. Could this distant world harbor alien biology? Is K2-18b the first exoplanet where we found more than just a hint of habitability? And what does this discovery mean for our own place in the cosmos? In this video, we'll explore the stunning new findings from James Webb, the mysterious nature of K2-18b, the science behind biosignature gases, and what might be waiting for us out there in the alien skies. K2-18b isn't just any exoplanet. It's what astronomers call a sub-Neptune, a world larger than Earth but smaller than Neptune, wrapped in a thick gaseous atmosphere. It orbits a red dwarf star named K2-18, located about 120 light-years, away in the constellation Leo. That might sound impossibly distant, but in cosmic terms, it's in our galactic neighborhood. Ever since its discovery in 2015 by NASA's Kepler Space Telescope, K2-18b has intrigued scientists for one reason. It orbits within its star's habitable zone, the region where temperatures could allow liquid water to exist. But that was just the beginning. What truly set this world apart happened when the James Webb Space Telescope turned its ultra-sensitive infrared eyes toward it. For the first time in history, we were able to peer through the thick clouds of an exoplanet's atmosphere with this level of detail. And what we saw was unexpected. Webb detected water vapor, methane, and carbon dioxide, gases that, together, suggest something very unusual is going on. But the real shock came with the potential detection of dimethyl sulfide, a molecule that, on Earth, is only produced by microbial life. If this detection is confirmed, it would mark the first time we've ever seen a potential biosignature on a planet outside our solar system, a chemical whisper from the dark, telling us we might not be alone. For scientists, this isn't just a new chapter, it could be the beginning of an entirely new book. So how exactly did James Webb uncover these clues? And what do they really mean? Let's break it down. When light from a star passes through a planet's atmosphere, certain wavelengths get absorbed by the gases present. Think of it like shining a flashlight through stained glass. Each color reveals something different about what's inside. Using a technique called transmission spectroscopy, James Webb captured the starlight filtering through K2-18b's atmosphere during its orbit. The light came back with telltale dips, like fingerprints, pointing to specific molecules floating high above the planet's surface. Among those fingerprints were familiar shapes: water vapor, carbon dioxide, and methane. On Earth, those gases are part of the delicate recipe for life. But it's the possible hint of dimethyl sulfide, DMS, that caught everyone off guard. DMS doesn't appear naturally in most planets. On Earth, it's produced almost entirely by phytoplankton, tiny marine organisms that live in our oceans. If this detection is accurate, it suggests that something biologically active may be lurking in K2-18b's atmosphere. Now, scientists are cautious. They know the universe can play tricks on us. Sometimes chemical reactions from non-living sources can mimic life. But Webb isn't the only eye in the sky. The Hubble Space Telescope had previously hinted at water vapor on K2-18b, but it didn't have the precision to see the full picture. James Webb, with its advanced infrared sensors, has opened a new window, and future instruments like the extremely large telescope in Chile or NASA's upcoming Habitable Worlds Observatory could soon add even more layers of evidence. If the readings hold up, it would mark the first serious evidence of a biosignature outside Earth. Not proof, but a deeply compelling clue. A single molecule in a vast alien sky might be whispering to us across the light years, begging us to listen more closely. Could we be standing at the edge of the greatest discovery in human history? Here's where things get even more fascinating, and just a little mind-bending. You see, K2-18b is located 120 light-years away. That means the light James Webb detected, the molecules, the possible signs of life, actually left the planet 120 years ago. In other words, everything we're seeing now already happened back in the early 1900s. Whatever is or was happening on K2-18b might have already changed completely. The signals we're analyzing are ghostly echoes from the past, traveling across the vast darkness of space to reach us just now. So, could we witness a grand event there soon? Maybe. Maybe not. It's unlikely K2-18b will explode like a dying star. After all, it's a planet, not a supernova candidate. But what we could see in the coming years are even more dramatic readings from its atmosphere. As new telescopes come online and Webb continues its observations, we may detect clearer, stronger signs. Imagine a future where we don't just find DMS, but a whole mix of gases working together in perfect chemical balance, like Earth's biosphere does. That kind of atmospheric harmony would be incredibly difficult to explain without life. The real explosion may not be visible in the sky, but in our understanding. A quiet, invisible detonation of human perspective. One molecule at a time. The universe might be pulling back the curtain on a truth we've only imagined in science fiction. We are not alone. Imagine stepping outside on a clear night, the familiar stars twinkling overhead. But tonight is different. One of those stars is suddenly brighter, so much brighter that it seems to have moved closer to Earth. At first, you think it's just a trick of the mind, but then it's unmistakable. There, in the dark expanse of the sky, K2-18b's distant light flares into view, shining like a second moon. Not a cold, distant point of light, but a full-blown spectacle, brighter than any star you've ever seen, glowing with a brilliant, almost ethereal radiance. For the first time in history, we could witness the birth of a new era in our search for life beyond Earth. The event would be visible even to the naked eye, a sight that could stretch across the globe. In some regions, it could last for hours, maybe days. The brightness of the flare would be enough to cast shadows on the ground, visible even in daylight. It would dwarf the brilliance of any comet, far outshining anything we've ever witnessed, and the implications would be monumental. The sky, once a silent void, would suddenly feel alive, pulsing with the possibility of discovery. For humanity, this wouldn't just be a celestial event. It would be a moment of reckoning, a once-in-a-civilization experience that reshapes our place in the universe. Could this be the spark that ignites a new chapter in human history, where we stop wondering and start knowing? This is the spectacle we could soon witness, an unforgettable reminder that we're not alone. This potential explosion, or rather the discovery itself, isn't just a cosmic spectacle. It's a gold mine for science. In a universe governed by gravity, the most extreme cosmic events, like supernovae or massive stellar flares, are the very moments when the universe creates some of its most precious elements. Elements like gold, platinum, and uranium, heavy metals that we find on Earth, are forged in the core of dying stars during these colossal explosions. When massive stars collapse, they trigger a chain reaction that produces these elements, scattering them throughout space. Over billions of years, this cosmic recycling gives birth to the very ingredients for life. If K2-18b were to harbor life, or even microbial organisms, we're talking about a shared origin with those stars that create these elements. Every atom in our body, every atom of everything around us, comes from stars that exploded long before our planet was born. The calcium in our bones, the iron in our blood, the oxygen in the air. All of it was created in the heart of long-dead stars. So when we discover a possible biosignature on a planet like K2-18b, we're not just finding evidence of alien life. We're seeing a reflection of our own cosmic origins. To put it into perspective, stars like Antares and VY Canis Majoris, two of the largest and most massive stars known, are examples of the kind of cosmic furnaces that produce elements we depend on for life. They're immense, burning brightly and ultimately dying in a spectacular fashion, scattering the seeds for the future of the universe. In the same way, K2-18b and its potential biosignature is a link to the deeper meaning of existence. It's a reminder that we are stardust, born from the heart of the cosmos, and that the universe in all its vastness is still unfolding before our eyes. Rest assured, Earth is perfectly safe from any immediate threat. While the explosion of a distant star can be awe-inspiring, it's not something we need to fear. The vast distance between us and K2-18b, 120 light-years, means that any cosmic event, like a supernova, would have no direct impact on our planet. We may see brilliant flashes of light in the sky, but they pose no danger. However, such events could have some fascinating atmospheric effects. Imagine auroras brighter than anything we've ever seen, dancing across the poles, or a brief surge in ionization that could make the northern lights more vivid and widespread. These phenomena would be harmless, though visually stunning. Astronomers are also prepared. With advanced neutrino detectors around the world, we now have the ability to detect the subtle particles emitted during stellar events before the light itself reaches us. This means that scientists could issue an early alert, giving us a heads-up well before the cosmic spectacle arrives, ensuring that we witness the event with wonder and curiosity rather than concern. As we look up at the stars, we're not just gazing at points of light in the sky. We're witnessing the final breath of a giant, a farewell millions of years in the making. The light we see from distant stars isn't just a simple spark. It's the culmination of a cosmic journey, a story written in the stars themselves. The very molecules we now detect in the distant atmosphere of K2-18b could be the remnants of a long-gone star, scattered across the universe, waiting for us to discover them. The scale of time and space is humbling. Each moment, each discovery, echoes across billions of years. In the grand expanse of the cosmos, we are but a brief flash, yet we have the privilege of understanding the universe in ways no civilization before us ever could. The light we see today may have traveled across centuries, yet in a way, it's still reaching us from the very beginning of time. So, as you stand beneath the stars, remember, the universe is full of hidden wonders, waiting for those curious enough to look up. Every glance toward the sky is a reminder that we are part of something much larger, an eternal, unfolding story written in the stars. Keep looking up, for the answers are out there. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. Let's continue this cosmic journey together. There's so much more to discover.